Hello children, how are you? I hope that everybody is staying home and staying safe. This is your Saubhagya Madam and I am back with another session. So children, in this session, let us learn the other two motions. Okay. So in the last video, we have learned about the translatory motion. And what are the two other types of translatory motion? I hope that you have understood what is translatory motion. So in this session, we will talk about the other important motion that is called as rotatory motion. What it is, children? Rotatory motion. Before I start the definition, let me show you something so that you can easily understand. Okay. See children, what is this? Yes, this is a wheel, right? See how it is moving. See how it is moving. It is moving in circle. Yes. Here if you observe, if this circle have to move, it is having a fixed point at its center. Right? See here, there is a joint for this so that it can move with the ability of this center point. So this center of attraction or this center of support is useful for the object to move in a circular path. In a circular path. Okay, children. So now let us first learn the definition so that we can clearly understand about rotatory motion. So if you see the definition now, rotatory motion, the motion of all particles of a moving body follow a circular path with respect to a fixed center or axis of rotation. So children, what it is saying is the motion of all particles. So whenever we are taking a body, all the particles present in that body have to follow. What they have to follow? A circular path. So what is a circular path? So if you take like this is a circular path. Yes. So all the particles of this body have to follow a circular path with respect to a fixed point. Okay. For this, let us take this is a fixed point. So what it is doing? It is rotating around or following a fixed point that is called as axis of rotation. Which is called as axis of rotation. So children, I'll give you one more example. If you see earth, if you think this is earth, you know that there is an axis of rotation on which we feel that the earth is rotating. Yes, the earth is rotating on a fixed axis of rotation. Yes, children. In your lower classes, I think you have heard this axis of rotation. It is an imaginary line on which the earth is said to be rotating. Okay, so as the earth is in a form of a circle, definitely it should have a fixed point on which it can rotate. So children, in the example that I have shown you, here there is a fixed point on which all the particles which are present in this body are moving in a circular path. In a circular path. I hope that you have understood what is rotatory motion. So children, we will learn few more examples so that you can easily understand what is rotatory motion. So children, let us repeat the definition once again. The motion of all particles of a moving object follow a circular path with respect to a fixed center or an axis of rotation. So if you take this example, here there is a fixed center. Here there is a fixed center, and if you take the example B, the earth, Here there is an axis of rotation. Okay, children. Either it should have a fixed point or an axis of rotation, so that then only you can say the object is showing rotatory motion. Repeat it, children. Rotatory motion. Give me a moment so that I can jot down few examples for you. Okay. Children, if you are having textbooks with you, please open page number 33. Okay. Please open page number 33. There you can see few pictures which are given regarding the rotatory motion. Okay, children? Fine. If you see your textbook part, here we have clearly given you few pictures. See here, you can see at top a fan, the wheels of a car, the hands of a clock, a giant wheel, and a globe. If you observe all these pictures carefully, children, if you observe any of these 6 pictures, you can clearly observe what is a rotatory motion. Okay. If you see a spinning top. So how does it move? It have a center point on which it can base, and the whole top can move in a circular motion. If you see a fan, a ceiling fan which is hanging on your ceiling, so you will have a head in the middle. Basing on that, you can see the wings of the fan, moving in a circular motion. If you see the wheels of a car, the wheels of the car are attached by an axle. Here, the axle is acting as a center of point so that the wheel can rotate in a circular motion. Okay. So, in all these examples which I have shown in the textbook, each of them are following a point, a center point to take some support. And also, if you see a globe, you can see the axis. There is an axis of rotation which is supporting the globe to move like this. If you observe it, I think you have seen the globe at your school. So what are the similarities that we are finding in the motion of all these objects? When you observe, each object is moving in a circular path. Yes, each object is moving in a circular path. Whether it is the top or the hands of a fan or the wheels of a car or the needles of a clock or a giant wheel or a globe. So, what is the path or the motion of each and every particle in it? Every particle which is present in the object definitely have to follow a circular motion. It is like a cycle or a circle. Whatever the cycle you are riding, the wheel of the cycle will definitely move in a circular motion so that your cycle move forward. Yes, children? Now my question is there any change in the position of the body while it is in motion? So children, here if you take the body part, whether there is a change in the position of the body or not when it is in rotatory motion. We will see an example. See children, if you see the hands of a ceiling fan, the center head doesn't move. Okay, it is at a firm point which is acting as a support for the hands of the fan to move their position in a circular path. Before you on the fan, if you see, the 3 hands of the fan are far away. But when you see the fan moving, once you switch on the fan, when you see the movement, you can see the three hands of the fan are moving in a circular path by changing their position. But here, the point of rotation or the fixed point or the axis of rotation doesn't move, but the remaining particles are moving or changing its position. So I'll give a pictorial representation of that. Okay, children? Okay, children. I have drawn a fan on the board. See, only I have taken only one hand of the fan. See, I have marked 3 points, point A, B and C. This is position 1. When I compare the position 1 to the position 2, if you see, the particle A have changed its place from point A to A1. Yes? If I see in the third position, here the point A1 have changed its position from A1 to A2. So children, in the rotatory motion, definitely the particles which are present in the object are definitely moving from one position to another position while they are in motion. Do you agree with me, children? See here carefully. The point A or the particle A is moving from A to the position A1. Yes. After few seconds, again this particle A1 have changed its position from A1 to A2. So definitely by this we can prove that all the particles which are present in the body are moving or changing its position while they are in motion. Okay, here there is a fixed point of rotation. Yes, if you observe, here we are having a fixed point of rotation. Basing on this fixed point of rotation, the particles are moving or changing their position from one place to another place while they are in motion. While they are in motion. So children, that is the rotatory motion that we have to learn in this class. So let me read the definition once again for you and listen carefully. The rotatory motion means that motion of all particles of a moving body follow a circular path with respect to a fixed center or axis of rotation. So children, if you observe here, every point, see, the B point is also changing to B1 and B2. And the C point is changing from C to C1 and C1 to C2 and so on. Yes, children? So all the particles are rotating or moving in a circular path. See how the fan will rotate in a circular path. Yes, it is rotating in a circular path with a fixed point of rotation. Here the point is fixed on which all the particles are showing a change in their motion when the object is in motion. So children, I hope you have understood this. For example, I'll give you a tennis ball. Now say me whether the tennis ball is in circular motion or in translatory motion. I have given a tennis ball to you. If you throw it on the floor, it starts moving. Yes? So now say me whether the movement of the tennis ball is having translatory motion or rotatory motion. Now we will see it on the board. Okay, children, I have taken a tennis ball. So I allowed this ball to, I throw the ball like this. Yes. So imagine that the ball is moving in this path. So according to translatory motion, here if you observe, all the particles which are present here are moving in a particular motion. Yes, if all the particles move along the motion, if all the particles are moving along the motion, then the object is said to be in translatory motion. If you see like this, the ball is moving in a straight line, so definitely it is showing translatory motion. Translatory motion. So now children, now if you take the ball itself, see, if you take, there are certain points, see, let us take few points here. So if you consider these points, so what are these points doing? These points are moving like this, yes? So they are moving, all the particles are moving in a circular path. Yes, maybe they are moving in translatory motion, but the particles present in this one are following a particular path, that is a circular path. So now you can say that the particles are following the rotatory motion. Why? Because if all the particles are moving in a circular path, then you can say that it is in rotatory motion. Yes, it is running linearly in a straight line. So it is in translatory motion. If you take both the motions into consideration, so the ball which is running on the floor will show two kinds of motions, both the translatory motion and the rotatory motion. Okay children, I hope you have understood clearly what is a translatory motion and what is a rotatory motion. Now we will move on to the next motion, that is called as oscillatory motion. Okay children, oscillatory motion. Give me a moment so that I can come back to you. Okay children, we'll come back to another motion that is called as oscillatory motion. Repeat it children, oscillatory motion. O-S-C-I-L-L-A-T-O-R-Y, oscillatory motion. So what is this oscillatory motion? The oscillatory motion is having a hip hop movement. So children, how they will go? Here the movements are having front and back movement or up and down movement. Okay. Here the motions are, the object will show the motion either in front and back movement or up and down movement. For example, we'll see the pendulum of a wall clock. If you see the wall clock, you will have a pendulum inside it. So whenever it is showing the movement, you can see the to and fro motion. చూడండి ఆ పెండులం ఎట్లా ఊగుతుందంటే ముందుకి వెనక్కి. Yes, it moves to and fro. So here it doesn't take any other movement. It just goes to and fro. Okay. If you are sitting on a swing, you went to a park and you are sitting on a swing. When you wanted to move in the swing, either you can go to the front and to the back. Yes, to the front and back. But you cannot do any other movement. To the front and back. Okay. If you see the needle of a sewing machine, మీ ఇంట్లో ఒకవేళ కుట్టు మిషన్ ఉంటే ఆ కుట్టు మిషన్ ఎలా పనిచేస్తుందో చూడండి. What is the movement of the needle which is present in the sewing machine? So when you stitch the cloth with the sewing machine, the needle have a property of moving up, down, up, down, up, down. So children, in all these three examples, you can clearly see the oscillatory motion. What you are observing here children? Oscillatory motion. So children, let us learn the definition of the oscillatory motion now. The to and fro motion of an object about a fixed point, always following the same paths, is called oscillatory motion. Here in this motion, the object have to move front to and fro. So along a fixed point, see, if you see the pendulum is hanging on the top and the pendulum hangs like this and it moves like this. Yes, to and fro, right children? So Here the action should be to and fro. No other action have to be shown or no other path have to be followed. The object have to move front and back, always following the same paths. ముందుకు వెళ్ళాలి వెనక్కి రావాలి, ముందుకు వెళ్ళాలి వెనక్కి రావాలి. Okay, so only such motions are called as oscillatory motions. What, children? Oscillatory motion. Okay, children, if you see this ball, observe it carefully. What is the motion that the ball is going through, or in which motion the ball is going or moving? See here, it is going front, back, to, fro, to, fro. Does it follow any other path? No. So here we can clearly see the pendulum of a clock which will move in the fro and two directions. Okay, children. So here the ball is hanging to a fixed point. The ball is hanging to a fixed point and the motion is in to and fro motion. Yes, the motion is in to and fro motion. So that now you can clearly understand what is an oscillatory motion. The motion which is following a particular path of movement, that is to and fro, and it is always about a fixed point. So it is having a fixed point here which is hanging to my nail. Yes, so here it is having a fixed point and the motion is following a particular motion. See, the path is similar to and fro. So in such conditions only we can say that the body or the object is following an oscillatory motion. The object or the body is following an oscillatory motion. So children, there are few examples that are given from our textbook. So let us have or think about that, whether they are in the oscillatory motion or not. A spinning top. A spinning top is following a rotatory motion. Why? Because all the particles are moving in a circular path. Okay. Bullet fired from a gun. The bullet which is fired from a gun will show the translatory motion. Why? Because it follows a straight path. It follows a straight path. The typewriter keys. The keys of the typewriter or the computer move up and down. So definitely they are in oscillatory motion. The motion of a potter's wheel. Kundal tayar jese kummari. It is in a circular path. So it is a circulatory motion. Motion of a vibrating sitar string. If you are playing a guitar or a sitar, in which way they are moving? They also follow an oscillatory motion, that is front, to and fro. A bouncing ball. A bouncing ball. A bouncing ball will touch the floor and get up. Touch the floor and come up again. So it is following a to and fro motion. So definitely it is also following an oscillatory motion. And sometimes we are seeing slow and fast motions. So children, you have learned three motions: translatory, oscillatory and rotatory motion. So in all these three types of motions, whether the object might move in a faster pace or at a slower pace. ఒక్కొక్కసారి చాలా ఫాస్ట్గా మూవ్ అవ్వచ్చు ఆబ్జెక్ట్, ఒక్కొక్కసారి చాలా స్లోగా కూడా మూవ్ అవ్వచ్చు. సో what is the path that we are choosing? For example, if you want to go to your school, what is the motion that you are choosing? So definitely we will choose a translatory motion. We want to go straight to the school and at a fast pace. Yes. If your mother asks you to take go to a shop or visit a shop or a grocery things, so what do? You will take a slow pace so that you wanted to spend some time enjoying outside your home, right children? So the motion is been seen, but sometimes the motion might be little faster or the motion might be a little slower. So children, that's all for this video. I hope that you have understood what are the different types of motions that I have taught. The three basic types of motions are rotatory motion, translatory motion and oscillatory motion. So here in these 3 points or the 3 kinds of motion, the object will follow a particular path along with the direction of the motion. So children, that's all for this video. Hope I'll meet you very soon in the next video. Stay home, stay safe. Thank you.